So today's question, my advice to you is to draw out the atoms that are going to be involved in the molecule. So here we're told we've got silicon, which has got 4 outer electrons. So you can see here's my 4 outer electrons. And it tells me chlorine has got 7 outer electrons. So I've got chlorine here with 7. Now this tells me it's a covalent bond. We need to remember that means they are sharing pairs of electrons. So hopefully by drawing these out, you can start to see how it's going to work. We're going to have need to share 4 electrons here, and this needs to share 1. So each one of these is going to bond here, and we're going to have 4 of them in the structure. So I've actually drawn this already to save a little bit of time with the work. So let me just reveal the answer, and then let me go through this with you. So as you can see here, my silicon does have 4, they're the crosses, and then each chlorine atom overlaps so that 1 electron is being shared, and then I've got these electrons here to form the rest of the electrons in the outer energy level. And as you can see, I've got 1, 2, 3, 4, 5, 6, 7, 8. So that is stable. And then my silicon in the middle has got 1, 2, 3, 4, 5, 6, 7, 8. So in total, there are 1, 2, 3, 4 covalent bonds being formed by sharing a pair of electrons in each case. In terms of marks for this, you're going to get 1 mark for showing that there's 4 bonds. 1 mark for showing there's 4 bonds. So 1, 2, 3, 4, and then 1 mark for showing the electrons that are not being used directly in the bond. Okay, next one down. Explain why simple covalent compounds have low melting points. So in my head here, if this image is really important because this here is a molecule and this is a molecule, but between the molecules we have weak forces of attraction. So that's how we're going to get the marks in this particular answer. So why did it have low melting boiling points? Because there are weak forces of attraction between molecules. And then we need to finish it off by saying these do not require a lot of energy to break, and that's why the melting point is low. In terms of marks, you're going to get a mark for that bit and a mark for that part. Okay, next we've got rubidium bromide. So here, let's just remind ourselves, this is ionic. We should therefore know it needs to have a high melting and boiling point. So of the options here, the only one that's really got the high melting and boiling point is going to be option D. That's got the highest melting and boiling point in this. It's going to be option D is the correct one. And the last question in this particular, the last part of this question here is asking you to explain how these two are arranged and then describe some properties. Okay, now again, just advice here. It wants us to look at diamond and graphite. So let's call diamond part A and graphite part B. So I'm doing 2 parts to this. I want to explain, number 1 for diamond is why it's the hardest material. So why is it hard? And I want to know why graphite is soft. So B part 1 is why graphite is soft. And then I want to be able to explain why diamond is a poor conductor. And then I want to explain why graphite is a good conductor. So it's kind of A part 1 and 2, and then B part 1 and 2 in order to get the marks for the question. So in terms of, let's do diamond here initially. So diamond is a hard material because this structure here, every carbon atom is got 4 covalent bonds. Those bonds are strong. And because it's 4 strong covalent bonds, it means the atoms are held in a rigid structure. So we need to say the carbon atoms form 4 strong covalent bonds, and this means that the structure is rigid. Why does that make it a poor conductor? Because all the outer electrons are used to make covalent bonds. So there's 4 bonds being formed. That means there are no delocalized electrons, and therefore it's not able to conduct electricity because there's no electrons that can move. If we now look at graphite, let's do part A and B for graphite. So why is graphite a soft material? So in this case, each carbon atom forms 3 covalent bonds. This means the structure forms layers in this giant covalent structure, and the layers are held together by weak forces. So you can see here, here's my layer, and here's my layer of carbon atoms, and then in between these layers are these weak forces. And because those forces are weak, the layers are able to slide, so the material is going to be soft. So this material, this layer will slide this way, and this one can slide that way. So it's going to be a soft material. In terms of why graphite is a good conductor, each carbon atom in this structure forms 3 covalent bonds. We know that carbon wants to make 4, so it's got delocalized electrons, and they are free to move and therefore conduct electricity. In terms of bullet points, I made it that there are 11 points I've got listed here. So a simple way to work out how many marks you got is look at how many points you've got and then allocate the number of marks. So for example, if you've got 10 to 11 of the points listed, you give yourself 6 marks. They're also going to look at, is your answer clear? Is it logical? And does it use scientific keywords? So getting words in there like rigid and covalent bonds and talking about the weak forces are key phrases to get into your answer.